likely remember when your phone's autocorrect could barely guess the next word in a text message without making a mistake. Today, artificial intelligence systems are writing complete college essays and debugging complex software in seconds. You type a prompt, and a wall of text appears almost instantly. The system weaves together entire blocks of code or dense legal arguments before you can even blink. When you read those responses, it feels like there is a mind on the other side of the screen. Back in 1966, a chatbot named Eliza was designed to mimic a therapist. People became so emotionally attached to it that they would ask researchers to leave the room so they could confess their deepest secrets to the machine. We are hardwired to project empathy and consciousness onto anything that talks back. Behind the blinking cursor of a modern large language model, there is no conscious mind. There is only a massive probability engine, pieced together step by step on a multi-stage digital assembly line. To understand why these systems hallucinate facts, steal copyrighted work, or output biased text, we have to strip away the illusion of a soul and look at exactly how this factory pipeline operates. The core engine driving this assembly line is the transformer architecture. Unlike humans, a transformer does not read a sentence sequentially from left to right. Multi-head self-attention simultaneously weighs the relationship of every word to find context. Zooming in, functions like queries, keys, and values rapidly multiply matrices to calculate relevance scores. Finally, softmax scaling converts these equations into a percentage probability for the next word. When you wait for an AI to finish thinking, you are really just waiting for high-speed matrix multiplication to guess the next token. An empty engine needs fuel. In the first stage of development, called pre-training, the transformer is fed a massive corpus of text scraped from the entire internet. The model acts like a super-powered eavesdropper, absorbing Wikipedia articles, global news streams, and thousands of books, all simultaneously. It learns language through a self-supervised method. It looks at a sequence of text, hides the next word, guesses what it should be, and then checks its answer. It repeats this cycle of guessing and correcting trillions of times. The result is a system packed with vast human knowledge, but zero conversational manners. At this stage, it exists solely to aggressively complete whatever sentence you start. If you ask this raw, pre-trained model a question, it might not give you an answer. Because it learned from web forums, it might just generate 3 more questions in response. To fix this, instruction tuning teaches the model to adopt the format and tone of a helpful assistant. Next, preference alignment uses human feedback to refuse harmful requests, outputting a polite decline instead of a step-by-step guide on embezzlement. Developers can also apply a process called fine-tuning. By running additional training passes on specific data, they can adapt a general model to a highly narrow domain, like transcribing the low-resource language Murad. Without these alignment and tuning stages, the raw mathematical engine is practically unusable for standard human interaction and potentially dangerous. Because the raw material for these models is the unfiltered internet, they inevitably inherit our flaws. The training data contains vast amounts of human toxicity, bias, and stereotypes, which the models will readily amplify if those safety guardrails fail. Then there is the physical toll. The computing power required to pre-train these models demands massive amounts of electricity, pulling millions of kilowatt-hours from the grid and emitting huge volumes of carbon dioxide. Developers are also fighting intense legal battles over copyright infringement and fair use, as the data scraped to build these corporate engines was taken from millions of uncompensated writers and artists. We cannot evaluate the success of an AI simply by checking its spelling and grammar. We have to measure the hidden societal, legal, and environmental damage left in its wake. The ethical blindness of creating artificial agents is an old problem. As a teenager, Mary Shelley explored the exact hubris of this scientific pursuit in her 1818 novel, Frankenstein. The book's subtitle points directly to our current predicament. Tech developers are unleashing massive language systems upon the public without fully guaranteed human alignment or foolproof safety filters. As these models integrate into our daily lives, we must view them strictly as reflections of our own human data. They are not omniscient oracles. Thoroughly understanding the mechanical pipeline, the scraping, the math, and the tuning, is humanity's best defense against being manipulated by the illusion of artificial magic.